comprehensive review on how to simplify radicals. It's broken into 3 sections pretty much. You have rational and irrational radicals. Then we're going to have rational and irrational with coefficients. And then the third one is going to be rational and irrational with variables and also with coefficients. So the first one, we're always looking to see, is the radical a perfect square? In this case, 100 is a perfect square. Remember, 100 can be written as 10 times 10, and then 10 times 10 can be written as 10 squared, and the square cancels with the square root. So the square root and the square will cancel, and that leaves you with the base. So that would just equal 10. These cancels with that because it's a square root. So your answer would just be 10. You don't have to show that work. You can go directly from 100 to 10. A lot of those perfect squares should just be basic mental math. 256. So I have no idea whether 256 is a perfect square. I could either break it down and look for perfect square factors, or I can just take my calculator and do 256, do the square root, and I get 16. That's going to be the easiest way. 144 is a recognizable one. I know the square root of 144 is 12. 16 is also a perfect square. I know that that's 4. So we should be able to recognize the square roots, the perfect squares, from 1 to 144. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, 16, 25, 36, 49, 64, 81, 100, 121, and 144. We should know those. We should recognize those perfect squares and know those by heart. So when we get to rad 32, if we don't know, if we can't remember whether it's a perfect square, if we hit 32 and hit the square root, we get this irrational number. 5.6568, 5424949238, and it keeps on going. It looks like it stops there, but numbers continue to go past that. This is called an irrational number because it does not repeat and it never ends. Now that doesn't mean that we can't simplify this, and our goal is to look at factors of 32. 1 and 32, 2 and 16, 3 no, 4 and 8, 5 no, 6 no, 7, and we're done. So these are the factor pairs, and when we look at these, we're looking for perfect squares. Can we break this up? Ooh, I like that, 16. So if I took this radical and broke it into rad 2, rad 16, I like this because 16 is a perfect square. I can simplify this expression. So we get 4 rad 2. The square root of 16 is 4, and then the radical always comes after. Let's say I didn't remember that 16 was a factor of 32, and let's say I just remembered 4 and 8. Or I thought, hey, 4 is a perfect square, so that's really good. So we would simplify it in this manner. We could do rad 4, rad 8. And we know that 4 is a perfect square, so we can simplify that. That helps us. And then you get 2 rad 8. And most people might stop there, but what's the problem? These are not the same. So that means that this one has not been simplified completely. And if we think about it, rad 8 can be written as rad 4, rad 2. And the reason why I broke 8 into 4 and 2 is because 4 is a perfect square. So we could still simplify this. This can be still simplify. And it's important to simplify these expressions, these radicals, completely. So this becomes, and then 2 and 2, these two are on the outside, so we can combine those, and we get 4 rad 2. And now notice these two answers are identical, so we know that we simplified it properly. It doesn't matter which factor group you choose, you just have to make sure that you simplify them completely. Rad 18, I'm going to break that into rad 9, rad 2. I chose rad 9 because it's a perfect square. This simplifies to 3 rad 2. Rad 20, I'm going to break that into rad 4, rad 5. That can be simplified. Whoops. To 2 rad 5. 72. So 72, okay, 9. Ah, yes, 9 rad 8. So I found or thought of a factor pair, factors that multiply to make 72, and that one of them is a perfect square. 9 is a perfect square. And a lot of you probably stopped here, and that's where you need to really be careful and recognize those radicals that can still be simplified. We still need to simplify rad 8. Remember, in the problem before, we could break rad 8 into rad 4, rad 2. That becomes 3 times 2 times rad 2. Remember, the rad 4 became 2. And that gives us 6 rad 2. 45, I know that 9 times 5, so that gives me 3 rad 5. And I keep saying the word rad, and rad means square root. And when I write that sign, yes, that looks like an R. I'm not really writing an R, I'm writing a square root sign real quickly. So understand that this is not an R, that's actually a square root sign. And rad is short for radical, because that's what this is. This is a radical sign. You can get square roots, cube roots, fourth root, fifth root, etc. So let's continue on. Rad 30. So if I look at the factors of 30, 2 and 15, 3 and 10, 4, no, 5 and 6. So I'm looking at these pairs, and I don't see any perfect squares. There are no perfect squares. None of the factors are perfect squares, so this is simplified. I can't simplify this anymore. This is simplified completely, so my answer would be just rad 30. Can't change it to anything else. This is our first one. Number 11 has a coefficient 5. When we see that, that's really 5 times the square root of 12. Square root of 12 can be broken into square root of 4, square root of 3. Square root of 4 is equal to 2. And now these are outside of the radical, so we can combine them, and we get 10 rad 3. 4 rad 80. 80. What am I going to break 80? Well, I know 4 goes into 80 20 times, and I can start. It doesn't matter which one. If you pick the biggest one, remember with this one, if you see the 16, that's great. But if you don't, and you use 4, another perfect square, it's fine. You'll still get to the same answer. You just got to make sure that you simplify it. So with rad 80, I'm just going to choose 4 and 20. I'm comfortable with that. I know 4 goes into 80 20 times. But now with 8 rad 20, I still have to simplify this. That has a factor, a perfect square factor in it. So just make sure that you simplify completely. 820 is not going to be 820. 8 rad 20 is not going to be acceptable as an answer. We would have to simplify that. Now this is our first negative coefficient. Doesn't change it. 144 is a perfect square. So I get negative 72. We have 5 rad 75. 75 I know that rad, oh, not 5, Mr. Mac 3. So we get 5 times rad 3, which is 25 rad 3. In recognizing numbers and their factors, that's why it's important to really know your multiples, your divisibility rules, all of those things. So 28, I'm going to do rad 4, rad 7. Why did I not choose 2 and 14? Because neither is a perfect square. So that doesn't help me. That's why I didn't choose 2 and 14. And I'd rather choose 4 and 7 because rad 4 can be simplified because it's a perfect square. Just reminding you why we choose certain factor pairs over other ones. 4 and 7, 4 times 7 equals 28, 2 times 14 equals 28, but 4 is a perfect square, 2 and 14 are not perfect squares. All right, number 16, now we have our first variable. So we're going to deal with variables different than we're going to deal with numbers or coefficients. Variables are written in exponential form, k to the 4th. And remember, when we have rad 16, that could be written as 4 times 4 or 4 squared, and we like that. That was beneficial to us. The square got rid of the square root. And so those two cancel and you're left with the base. When we have k to the 4th, well, remember we want squares because squares get rid of our radicals. So I know that k squared times k squared equals k to the 4th. So I'm going to split it up into those two things. The square root of k squared. Why did I choose 2? Because it's going to cancel with this radical. Why did I choose this 2? Because it's going to get rid of this radical. And they'll cancel. You'll be left with your base. So this one produces a k. This produces the base of a k. And then my answer is going to be 4k squared. So we get 4k squared. 180. Ooh, 180 is an interesting one. So, well, 9. I know 9 goes in 18, so we can do rad 9, rad 20. I like that. And then we have rad p squared. So rad 9 gives us 3. Rad 20, before I write my final answer, I know that that can be broken up. The square root of p squared gives me p. No more radical outside there. The rad 4 is 2. So we have on the outside, we have a 3, a 2, and a p. And still in the radical is rad 5. So we're going to combine those things on the outside. 3 times 2 times p gives me 6p, and then rad 5. So that's how we would write that. The radical is always going to come last. Coefficients. So this is the square root of 200 and the square root of b to the 4th. Square root of 200, I'm going to write square root of 100 times square root of 2. B to the 4th is going to be b squared, b squared. So that's 10 times rad 2 times b, which is 10b squared rad 2. We have the 10, we have the 2 b's outside, which makes b squared, and then we have that radical left by itself. Rad 64, rad k squared. 64 is a perfect square, that equals 8. K squared is a perfect square, and that equals k. 20, a to the 3rd. Rad 20, rad a to the 3rd. So rad 20 gets broken into rad 4, rad 5. Now, remember how I broke those up? Well, there's only 3 of them, and I want to do pairs of 2. So I can only do one pair of 2 because a squared times a gives me a to the 3rd. So I only have an a squared times rad a. Rad 4 becomes 2. Rad 5 can't be simplified. Rad a squared gives me an a, and then I have a rad a. So what's left on the outside? I have a 2 on the outside, an a on the outside, and then I have a rad 5 and a rad a on the inside. So we're going to combine those. You get 2a rad 5a. Ooh, that's a good one. If you did that one right, if you got number 20 right, you're going to do well. And 21 is going to be hard too, also, by the way. So rad 108. Now we're going to separate x to the 4th and separate y to the 3rd. 108. I don't remember. I know I've done 108, but I can't remember it. But 9 and 12. And that gives me 3. Rad 12 is rad 4, rad 3. So that is 3 times 2 times rad 3. X to the 4th is going to be rad x squared, rad x squared. So that gives me an x and an x. So that produces x squared. Y to the 3rd, well, I have 1y squared, and then I have a rad y. So that's y rad y. Y rad y. So stuff on the outside. Outside are 3 times 2 times x squared times y, which gives me 6x squared y. And then I have rad 3 and rad y. So rad 3y. All right. If you got 21 right, then you're probably going to do well. 245, holy moly. 245. So I'm going through my perfect square list. My perfect square, 1, 4, 9, 16, 25, 36, 49, etc. So 1, we discount because that doesn't help us any. Square root of 1 gives us 1 and that original number. 4, does 4 go into 245? No. Does 9 go into 245? 2 plus 4 is 6, plus 5 is 11? No, 9 does not go into it. 16, I have no idea. Let's try 245 divided by 16. Nope, so that's not a factor. 25, I know 25 doesn't go into 245. 36, all right, 36, let's try 245 divided by 36. Nope, doesn't go in evenly. All right, so I could continue, I could try 49, but what's better, not better, oh shoot, didn't mean to do that. Another technique that you can use is you can do the prime factorization of 245. So I know 5 goes into 245. And so I can look for the prime factors. 245 divided by 5. I know that it goes in because 49. So I just didn't have enough patience. And I know that 49 is a perfect square. So sometimes we want to break up our number, our original number, into its prime factors. And I don't know if I even tried this. Did I even see if 245 was a perfect square? Which it is not. So 245, and then the square root of a, the square root of b squared. 245 we're going to break up into rad 49, rad 5. Notice I wrote the perfect square first. Square root of a cannot be simplified, and the square root of b squared gives us b. So that's 7 times rad 5 times rad a times b, which can be written as 7b rad 5a. So these are the nitty-gritty ones. These are probably the hardest ones. So this is really your test. If you're getting these right, then you're going to be prepared. 196 square root equals 14. So 196 equals 14. Square root of a squared. Square root of b to the 4th. Square root of a squared is a. Square root of b to the 4th is b squared. So 14ab squared. Number 24, rad 18, rad x squared, rad y squared. 18 I'm going to break into rad 9, rad 2. Square root of x squared is x, square root of y squared is y, square root of 9 is 3, rad 2 times x times y, so my answer would be 3xy rad 2. 25, rad 50 times the square root of x to the 4th times the square root of y to the 3rd. 50 gets broken to rad 25 rad 2. X to the 4th is x squared. Y to the 3rd is y rad y. 5 square root of 2 x squared y rad y. So outside stuff, 5x and y. Inside stuff, rad 2 rad y. So we get 5xy rad 2y. All right, now we are dealing with coefficients. So we have -8 times the square root of 63 times the square root of x to the 3rd. 63, I'm going to do rad 9 rad 7. And square root of x to the 3rd is x rad x. So -8 times 3 times rad 7 times x times rad x. So that gives me -24x rad 7x. -8 times rad 200 times rad a. Rad 200 can get broken to rad 100 rad 2. Rad a can't be simplified. -8 times 10 times rad 2 times rad a. -80 rad 2a. Number 28, 8 times rad 180 rad p squared. 180, well, I know 9 and 20, and that gives me p. That'll give me 8 times 3. Rad 20 can be broken into rad 4, rad 5. So we get 8 times 3 times 2 times rad 5 times p. 8 times 3 is 24 times 2 is 48 p rad 5. Make sure the things on the outside come first in front of the radical. Let's look at 29. You have 7, 63. I think we already did. Rad 9, rad 7. Rad x to the 3rd. So that's 7 times 3 times 7 times x rad x. 7 times 3 is 21x rad 7x. Moving right along, got a nice little pace to this. 2, we're 108 again. I keep forgetting what that shortcut is. I know that there's a bigger number than 9 that can go into it. 9 and 12, rad a to the 4th, 2 times 3, rad 4, rad 3, and that becomes a squared. We get 2 times 3 times 2 times rad 3 times a squared, which is 6, 12a squared rad 3. Different letters finally. 3, 48. Well, rad 4, rad 12, rad u to the 3rd, rad v squared. 3 times 2, rad 12 can be simplified. U to the 3rd is rad u. V squared is v. 3 times 2 times 2 times rad 3 times u rad u times v. Woo! Keeping track of it. 3 times 2 is 6 times 2 is 12 u v rad 3 u. So how do you keep track of all the things that you've done? that's probably where most of the mistakes will be made, is you lost a piece in your notes. So take your time, write clearly, make sure you are notating and keeping track. So rad 75 is rad 25 rad 3, rad x squared is x, rad y cubed is y rad y, times 5 times rad 3 times x times y times rad y. So that's 30 xy rad 3y. Couple more. That's a -1 times the square root of 100 times the square root of x squared times the square root of y to the 4th. So it's -1 times 10 times x times y squared, which gives us -10 xy squared. Alphabetical order, variables should always be placed in alphabetical order. Number 34, 2 times the square root of 100 times the square root of x to the 4th times the square root of y. 2 times 10 times x squared, and then rad y can't be simplified. So you have 20x squared rad y. Last one. You have a -1, square root of 64, square root of x to the 3rd, square root of y. -1 times 8 times x rad x rad y. -8x rad xy. So you're combining those variables because they're both under the radical. All right, that's some good stuff right there. Hopefully you understand it. Good luck on the assessment.